Good morning, everyone. Good morning. Hope all is well. Everyone's all right. All right. Before we get going and rolling on my end, anybody have any questions, any problems, anything they tried, got stuck on? Everybody good? Anybody have anything? All right. Everybody's okay. All right. So let's see. Where are we in our notes? Last class, I believe we did scientific notation. Should be looking at factoring today. $13.1 greatest common factor. Checking one more thing before we get rolling, and then we'll get going. Someone says in chat. All right, so do you have, excuse me, do you have a problem like that? So I can know exactly what you're talking about. All right, so while we wait on that response, we can go ahead and get going into 13.1, and I'll make sure I address your question before we leave. So 13.1 greatest common factor. We're getting into factoring. When you look at factoring, factoring is going to be the undoing or the reversal of, I won't say the undoing, it's the reversal process of multiplication of your, well, you could say undoing, multiplying out your polynomial. So in other words, if I had x times 2x plus 5, the result when I multiply that out would be 2x squared plus 5x, because x times 2x is 2x squared, x times 5 is 5x. So factoring is taking it back to this. So I would have 2x squared minus 5x, and I'm taking it back to 2x plus 5, and then the x on the outside. So that's what factoring is. And in this case, the GCF, the greatest common factor, would have been the x. So it's the greatest common factor that I can pull out of each term that I see. All right, so the first exercise in this section would be something of this nature. It says identify the GCF. So they give us 40, 52, and 32. And this first step we would take on is to take each number and break them down to prime numbers. Break them down to the prime factorization. So there are different ways you can break it down, but when you're finished, you'll still have the same prime numbers. So I looked at 40 and broke it down to 4 times 10. You could have done 2 times 20, 5 times 8. Either way, when you're finished, though, you'll still have the same 4 numbers, which is 2 times 2 times 2 times 5. So like I said, I broke it down to 4 times 10, took the 4, broke it down to 2 times 2, and then took the 10, 2 times 5. So we have this final breakdown, breaking down 40 into prime numbers. 2 times 2 times 2 times 5 still multiplies back out to give me 40. That's how you always can check your prime factorization. If it doesn't multiply back out to give you what you originally had, this is not the correct factorization. But you would just start off with 2 numbers, then break that down to 2 numbers, break the other number down to 2 numbers, till you can't break them down any further. Same thing with 52. I did 2 times 26. So that was, 2, you can't break that out and down any further. 26, you break it down to 2 times 3. I said 13, 2 times 13. And then with 32, I decided to use 4 times 8. Then 4 is 2 times 2, 8. I should do this. 4 is 2 times 2. And then 8 is 2 times 4. Now I can't break down 2 any further, but I can still break the 4 down into 2 times 2. So I just put a box around, my prime numbers. So when I compare what I have, once again, 4 is 2 times 2 times 2 times 5. 52, 2 times 2 times 13. 32, 2 times 2 times 2 times 2 times 1. So that was my prime factorization of each. So before we pull out the GCF or talk about pulling out the GCF, questions on how we got those prime factorizations.
I ain't got no question, but just slow down for us, please.
All right, so that GCF, you see what I wrote in the purple. GCF will be all the numbers or variables that each have in common. So in this case, the only thing that all 3 have in common would be 2 2s. So 2 times 2 would be 4. Our GCF would be 4 in this case. All right, are we good to scroll up some? Let me know. Straight, are we straight? All right. So next one, we want to do the same thing. We have 28 mn, 24 m cubed n. This time we have variables, we have letters that could be a part of the GCF as well. Once again, if I scroll up, you still copy and let me know. So I take the same thought process with the 24 and the 28. And the more you do this, the more you get used to the process. You may not have to, break them all the way down like this. You may just see numbers. Same thing with these. You may not have to break them all the way down. But this process will always work for you if you don't see any type of connection or if you don't see the GCF. So looking at 24 and 28, I could just take the 4 out of each, but just keeping in the same practice. So what I did earlier, I'm breaking them all the way down to prime numbers so we can see the connection. But if you just see the 4, that's in common with both, then you don't have to break them all the way down. And it's my hopes that, the more you do this, the more you get comfortable with it, the less you have to, write out every single piece of the process. But 28 is 4 times 7. 4 would then break down into 2 times 2. So we have these two pieces and then the 7. 7 you can't break down any further. And then with 24, that's 4 times 6. And then you have 2 times 2 and 2 times 3 as a result of those two numbers. Over here, writing it all together, 28 mn is 2 times 2 times 7 times n times n. And then 24 m cubed n, 2 times 2 times 2 times 3. And then you have 3 m, so that's m, and then 1 n. Then from there, you say, what do they have in common? So you notice we have 2 2s, 1 m, and 1 n that they have in common. So 2 times 2 would be 4 mn. Any questions? Any questions?
Yes, sir.
All right, all right. All right, can we scroll up? So we're gonna do more with that in a second. But we do want to introduce what it means to be prime. It says an expression is prime when it cannot be factored at all. Like done with that last problem. All right. Next one says factor out the GCF if possible. So if there's nothing that we can factor, then you can write prime. That's not going to be the case with this one, but that's why they went ahead and introduced that. Because now they're giving you an expression and they want you to write it, factor it out as much as possible. Here we have 12r cubed minus 18r squared minus 30r. All right. So when I look at the GCF, so like I said, I do want to try to, condition us to not have to break them all the way down. And so in this case, let's look at the 12, 18, and 30. 12 is 2 times 6. That's what I have in the blue circle. 12 is 2 times 6. 18 is 3 times 6. 30 is 5 times 6. So I'm trying to, like I said, condition us to not have to break it down every single time. I notice that I have a 6 in each one of those terms. So my GCF would be 6. And then of course you do evaluate what you have left to see if anything else is in common, but you just have a 2, 3, and 5. So you pull the 6 out of each term, but also we have 3 R's in the first term, 2 R's in the second term, and then 1 R in that third term. So at the most you can pull out is 1 R, at the most that they have in common is 1 R. So that's why our GCF is 6R. There's a 6 in each number. Also, there's an R in each number. So before we go any further, is everybody okay with our GCF being 6R? All right. So if I erase this, we'll walk through it. So that means what you know is going to have to happen is that you're going to have 6R on the outside and then parentheses. And for each term, there has to be a term here. So if you have 3 terms, then there should be 3 terms in the parentheses. Because remember, what this is going to represent is the multiplication of that original expression. When I multiply 6R back to each term, it should give me what I originally had. All right. So looking at this first term here, 12R cubed, if I take 6R out of it, I'm going to be left with that 2. And then I took one of the R's away, so it's 2R squared. Right. Here, 18, take the 6 out of the 18. That's going to be 3. Take one of the R's away, that's 3R. And then here, take the 6 out of that 30. You're left with 5, and I took that R with me. So it's just 5. So that would be the result. Questions on anything? All right, can we go to the next one? Pretty good. All right, next one we have 12AB to the 5th, C to the 3rd, plus 16A to the 4th, C squared. So 12 is 4 times 3, 16 is 4 times 4. So I can factor out that 4. Then when we look at our A's, the first term has 1A, the second term has 4 A's. So I know I can at least pull out 1A from each. And then the first term has 3 C's, where there's no B's in both of them. There's only B in one term, so you can't factor out B. But then we go to C. We have 3 C's in the 12 term, or in the first term, and then the 2 C's in the second term with 16. So I can pull out at the most 2 C's from both of them. And so that's why our GCF is 4AC squared. So you just take each piece and analyze, do I have, or how many of those do I have in each term? How many of those do you have in each term? Pretty good. So once again, whatever I say the GCF is, that's what's sitting on the outside of the parentheses. So 4AC squared. Whoa, go back. Okay. So 4AC squared. Then on the inside is going to be what's left. I took 4 out of the 12, so I'm left with 3. I took the A that's sitting on the outside, so there's no longer A in that term. Then I had B to the 5th, but there was no B terms over here, so I couldn't even factor that out. So that B to the 5th stays the same. And then I took out 2 C's from this 3 C's. And so that left me with 1 C. Remember, when you multiply back out, you're gonna get this back. So. And then on that next term, take 4 out of 4, excuse me. Take 4 out of 16, that leaves you with a 4. As far as A is concerned, I took one of these A's, so I'm left with 3. Then I took both C's out of there. That's why there's no C there, because it's sitting out here in the front. Questions. All right, scroll up. All right, so this next exercise specifically tells you to factor out a -1, and that's all they say do. So that means you're going to pull a negative to the outside of your parentheses. And all that does is it changes all of the signs of your original expression. So notice now the minus sign is sitting out front, and 5t is now positive, 3t is negative, and 4 is negative. So that's what this process does for you. If you pull a negative to the front or pull a negative out of each term, it changes all of the signs of your terms. All right, next one, doing the same thing. We have 7x to the 5th minus 8x cubed plus 3x squared minus 9. If you pull a negative to the front or extract the negative out of each term, then each one of your signs will change. So we had a positive 7x to the 5th originally. Now we have a negative 7x to the 5th. Then it goes to a positive 8x cubed minus 3x squared plus 9. All right. Questions. You sure we're okay? I think that was it like that one. Yeah. All right. And I scroll up. Really good. All right, so we're back to factoring out the GCF if possible. All right, so here we have 9a to the 4th b minus 18a to the 5th b plus 27a to the 6th b. First term is 9. Second term, when you look at it in terms of 9, is 9 times 2. Third term is 9 times 3. So we know we have 9 in common with all 3 terms. Then when we look at our A's, we have 4 A's in the first term, 5 A's in the second term, 6 A's in the third term. So at the most that we can pull out of each term is the 4 A's. You know, it's the smallest number out of all of them. So we can pull out 4 A's, and then there's a single B in each term. So we can take that as a part of our GCF as well. All right. Questions? Any questions?
I got a question.
Yep.
Hmm. I don't understand why it's 9A. I don't understand that part.
You say you say when you say 9A, what you mean?
How we simplify, what do we do? Because I'm lost in how we got to GCF. It's just 9AB. That's what I'm lost at.
Okay. Okay, cool. Because now just want to make sure. So we're not finished with the problem as far as factoring. I was just making sure we were cool with getting that GCF. So the first thing you want to do is look at each term, and we're looking at the numbers first, not the variables. So we're looking
Okay.
at each number and saying what's the largest number that they have in common. So we know this number is 9 because it is 9, right?
Yeah.
Um, Now this next one, 18, when you break it down, that's 9 times 2.
Right.
And then 27 is 9 times 3. So when you look at all three numbers, the largest number that they have in common is the 9. It has 9, 9, 9, and 9 in all three terms.
All right. I got that part down. When you get to the second part, man.
Okay. So now when you look at A, now you look at each piece, individually. We have 4 A's, A to the 4th in that first term, 5 A's here because it's A to the 5th, 6 A's here because it's A to the 6th. Now, when you look at each one of your terms, you say, well, if I have 6 A's over here, 5 A's in the middle, and then 4 A's in my first term, what's the most amount of A's that I can pull out of all three? And it's only 4 because I can't take 5 A's out of this first term. You know what I mean? I only have 4. So
Right.
remember, your common factor is what can you pull out of all three terms?
Okay. I got
So,
you.
so the most that you can pull out as far as A's are just the 4 A's. And then you see that we have a B that's in common with all three.
Okay.
Yeah.
Yeah.
All right. Cool. Not a problem. So now remember when I talked about, let me erase this. Remember when I talked about before that the GCF is what's going to sit on the outside of the parentheses. Now, if I have 3 terms here, I need 3 terms in my parentheses as well, because this is going to multiply to that to give me what I originally had, multiply to this, and then multiply to this. So I can't have 3 terms in my original problem and then have 2 terms in my parentheses. It has to be 3. So let me erase this. So now if we notice, this GCF is the same thing as this first term. If that ever is the case, then that means that what goes in the parentheses is a 1 right there. So in other words, when I go to multiply this back out, 9A to the 4th B will times 1 will give me 9A to the 4th B. You know what I mean? So whenever your GCF is the whole term, then make sure you put a 1 there for that term. So when you multiply it back out, you can still get what you originally had. All right. So the next one, if I pull 9 out of 18, I'm left with 2 because 9 times 2 is 18. Then I would take 4, excuse me, take 4 A's out of the 5 A's. So that will leave me with an A. And then that B is right there. So I don't have to rewrite that. I wouldn't rewrite another B. Because remember, this has to multiply to this in order to give me that. And then the last one, if I take 9 out of 27, I'm left with this 3. And then I took 4 of the A's. So that'll leave me with 3A squared. Once again, the B is right here in the front. All right, questions on that? Got one more, and then I think we got this. Yep, okay. So 15y cubed plus 12y to the 4th. Once again, we're looking to factor out the GCF. So we're over here. Out of 15 and 12, they have a 3 in common. because 15 is 3 times 5. 12 is 3 times 4. So we know they have 3 in common. Then when we look at y cubed and y to the fourth, at the most that I can pull out of both terms would be the 3y's, y to the third power. All right. Any problems? So if I'm going to pull 3y cubed out of 15, take 3 from out of the 15, you're left with 5. And then I took all 3 of the y's, so that's what's going to sit out front. So it's just 5. Then 3 out of 12 leaves you with 4. Then I took 3 of the y's and placed it out front, so that leaves me with 1 of the y's. All right, questions. So the next one, we have another situation where they tell us specifically what to factor out. So they tell us to factor out -3 from -3x squared plus 6x minus 33. So we're going to pull out 3, but we're also going to factor out that negative. So it's going to change all of our signs as well. All right. So pull -3 to the outside. So from the -3x, that'll leave you 3x squared. That'll leave you with just the x squared. I had a positive 6x. So that when I pull the -3 from it, that'll leave me with -2x, because -3 times -2 will give me positive 6 back. Then I had a -33. So I pulled -33 from it. That'll leave me with a positive 11. Once again, when I multiply this back out, it should give me what I originally had, or it's not the correct factorization. All right, questions, any questions? All right. So the next one, this is the original problem is in black. So we have 2w, x plus 3 minus 5 times x plus 3. So they want us to factor out the GCF. This is going to set us up for the next method, next thing that we're going to do. So over here in the purple, I want to simulate what is happening here, what is happening here, so we can try to make sure we have the same thought process. If I have y that's in common with both of my terms, I pull the y out front, factor out the y, and I'm left with whatever's left, which is 2w minus 5. All right. So like I said, over here, I'm just simulating what's going on over here with smaller terms. So we do the same thing here. It's just that x plus 3 is the GCF. So we bring that out front. And then what's left is the 2w minus 5. So the same thought process that we use here is what we use over here. Questions? All right, next one, same type of deal. 6 times x squared plus 4 plus y times x squared plus 4. So what's in common is the x squared plus 4. So you bring that out front, or down front, or whatever you want to say it. And then what's left is 6 plus y. All right, questions on anything? Make sure we're okay. All right, so factoring by grouping, last thing out of this section. This is what we're going to use whenever we have 4 or more terms, factoring by grouping. All right. So first one here, 3ax plus 12a plus 2bx plus 8b. So we want to group together the first two and group together the second two. So it's called factoring by grouping. We're going to group together our terms. Then we're going to find the GCF of each and go from there. But that's why it's called factoring by grouping. Now, I don't believe you guys will see any problems like this in this class, but you could factor by grouping, realize that this grouping didn't work and then have to go back and rearrange terms and stuff like that. So, if you go to another class or something like that, you may have that type of scenario. I don't remember seeing anything like that in this class, but just throwing it out there. So once you group together your terms, you're going to factor out your GCF out of each. So here, I factored out 3a. So it was a 3 and an a that was in common with both terms. And that left me with x plus 4 in my parentheses. Here, I factored out 2b from each term. And that left me with x plus 4 in the parentheses. All right. Now at this point, notice we have x plus 4 that's in common with both expressions. That has to happen or you cannot move any further. If you don't see the same thing in parentheses, you cannot go to the next step. So notice what the next step is, which is what we did in the last problem. We'll bring the x plus 4 down front, and then what's left is 3a plus 2b. All right. Questions on what we did there? Over here, previous students were just asking me, could you write it this way or that way or whatever? So I was just showing different ways that you could express the answer. Notice that what's in the parentheses are the same. So you don't mix up 3a and the 4 or 2b and the x. X plus 4 is in one parentheses, 3a plus 2b is in the other parentheses. So that would be considered the same. Questions on what we did there before we do another one? All right. So 16W minus 40W cubed minus 12W squared plus 30W. All right. So we have four terms. So just like before, we're going to group together the first two and second two. One thing I do want us to make sure we're aware of is that this minus sign right here, make sure you don't put it out here. Make sure it is included inside of the parentheses with the 12W squared. That is a part of 12W. If you separate it with parentheses, you will get something different. You will be changing the value of the problem. So what we have here is positive 6W to the fourth, negative 40W cubed, negative 12W squared, positive 30W. And those values are supposed to hold true. All right, no matter what you do as far as breaking it apart. All right. Any problems with the breakup before we look to factor? All right. So 16W to the fourth minus 40W to the third. What I factored out was 8. So you notice 16 is 2 times 8. 40 is 5 times 8. So I pulled 8 out of each term. And then I pulled 3 W's from each term, which leaves me with 2W minus 5. The next one, I have 12, which is 2 times 6. 30, which is 5 times 6. So I'm going to pull a 6 out. And then we have W squared and W, so I pull W with the 6. Now, if I notice, I also pull this negative out. Notice if I didn't do that, then each one of these signs would be different. But remember, I need 2W minus 5. So in order to ensure that I get 2W minus 5, you have to pull a negative 6 out. So you can get, like I said, 2W minus 5. If you didn't, like I said, what you would have saw was negative 2W plus 5. Then you would have recognized that you're not the same, and then you would have had to pull out the negative. So that's why you pull out negative 6W. All right, make sure we are okay. So we have 2W minus 5 that's in common with both. Bring that out front. Then what's left is 8W cubed minus 6W. Any problems? Any problems? All right, so one last thing. Notice I said always check your groupings for GCFs. Always make sure that this factored as much as possible before you say that you have your answer. So if you notice, hold on. Yep. So if you notice in my second grouping, they're both even. So that means if nothing else, I can pull a 2 out. And then also you see that both of them have a W in common. So I could have pulled 2W out from each one of those. So I go ahead and do that. So I pulled 2W out of both of these. So that's why it's 4W squared minus 3. And normally you put your GCFs, out front. So that's why I pulled a 2W, brought it all the way out here. Questions on what we did there? And so with that being said, you always want to look to factor out your GCF first. So at this point forward, when we go do our factoring, we'll factor out the GCF first, like we were doing, initially. All right. Any problems? All right. Let's go up. All right, everybody good? Before we I know we had a question on floor, so I wanted to address one of your classmates' questions. All right. So all right. So Davon, I think I'm saying it right. I think I'm saying your name right, Davon. Make sure I'm saying it right. Feel free to say yes or no. I think that's what we discussed. But is this problem correct? Is this the way you said? I think you said the x is squared. Okay, cool. So you want to know, is it a linear equation or not? Just want to make sure I'm cool on the directions. If it was a linear equation, it would not have this square up here. So because of the square, it's not linear. All right, so it's not linear. So a linear equation is just going to have the power of 1 on both of your variables. So if any of those powers are different, then it's not linear. So if it was negative 6x minus 3y equal to 0, then that should be linear. So you want the power of 1 on both of your variables. So from that, yeah. All right. So any other questions on anything? Questions, concerns, comments? Everybody good? I know Davon, if you had another one, feel free to let me know. All right, so let's look at, let's see. Let's see where we, now you're behind as far as lecture is concerned. So his question was, I hope you don't mind me sharing with the class because it might help somebody else. If he's still on 10.2, is he behind? So now you are behind as far as lecture is concerned. So you do want to get caught up at some point because we have a certain amount of content that we're going to cover. We are, that was 10. So we did 12. We're in 13 now. So we have 1, 2, 3. So counting 13, we have 4 more chapters to cover. And so we're supposed to cover those things. So we had chapter 10, 12, and now we're in 13. I mean, it's not the worst thing in the world, but you do want to get caught up because we, like I said, we're in chapter 13. We started 13 today. And we don't really have the luxury to not do anything like a whole, a lot, as far as just like not doing anything at all. So you do want to start looking to get caught up. The lecture is the gauge. You look at the lecture and say, okay, I do have till, whenever to do this work, but if you get too far behind, you won't have time to get caught up. because next thing you know, it'll be December. This time don't play. So you don't want to sit on this stuff too long. So we don't have to do another section today. I can let y'all sit on that. That's 13.1. But take advantage of the fact that we only did one section. And next class, we'll look at trying to factor trinomials and move forward in our factoring. But yep. We want to make sure we are, like I said, using the lectures as our gauge, and then try to make sure we keep in pace with the lectures and everything like that. All right, x plus y equal to 7. How would you graph that? Okay, so let me get back to the notes page because I know you guys are on it. All right, so we have x plus 7. Oh, not 7. X plus y equal to 7. So you can create an XY chart. And MATLAB only asks you for 2 points when it comes to the line. So you can use 1 and 0 if you like. But you choose, unless they give you some points, you choose these X values here. So you can use 1 and 2, you can use 5 and 10, you can use whatever you want. Just remember, whatever you choose, you have to graph it. So then from there, you plug in the value for X and solve it for Y. So that's 1 for X equal to 7. Minus 1 from both sides. Y is equal to 6. So when X is 1, Y is 6. And then plug in 0 for X. Y plus 0 is just 0. So that's 7. So when X is 0, Y is 7. So you choose X's, plug them into your equation, find the corresponding Y value. So when X is 1, Y is 7. When X is 1, Y is 6. When X is 0, Y is 7. And then from there, you graph that. All right, so you go to the right one, up 6. Then 0 is nowhere for X, but then you go up 7. And connect the dots. That's your line. All right. In MATLAB, there's a button top right corner where that just look like that. And you will click on that button, and then it will help you graph the lines. You just click on the 2 points where you want to graph, and it'll create the line for you. Where it's like, it should be like top right corner. Right. Questions? Any other questions? Make sure we're good before we close out.
I have one question. So do we still email Mr. Davis for the tests?
Yeah, if you want to take that now, has he not been responding or something?
For the first one, but then you did that class thing where we can come in and took the test. So I was just wondering if we still email him.
Well, if you don't want to wait for those type of moments during class, then yeah, you would. Like if you're ready to take a test now and I haven't set up one of those days, then yeah, you can just go ahead and email them. But if you want to wait for me, then because anytime I really do it will probably be on a Friday or something like that.
Okay.
But I will give you guys a heads up. So maybe look towards next Friday doing it.
Okay, and if we do email him, do we email you as well?
Yeah,
or is it just him?
Well, CC me in it because that way I can validate or that hey, they did email you. Because when you just email him, and I'm not trying to say he would do this, but when you just email him, then it's just your word against his. Now he's never done that. I'm just just making sure there's a paper trail for you. So that way you CC me, and if there is ever an issue, you can be like, hey, well, I emailed him back on such and such, and if he never got the email, then I can vouch for you. But let's say technology happened, he never got the email. Then you say, but you say you did it, let's say a couple months ago. Well, we have a lot of students that try to, get over on stuff. So that way this covers you, you know what I mean? And it's not like you're just somebody who's trying to get over, you know what I mean?
Yeah.
So yeah, so that's really what it's all about. It's not saying that Mr. Davis is a shady dude. If he was, I wouldn't send you to him, you know what I mean? So it's just that, we want to make sure you cover it because technology happens all the time where stuff don't always do what it's supposed to do. And this way, there are at least two people that should have gotten that ping on your email.
Yeah, I got you. Thank you.
Yep, not a problem. Anything else? Anybody else? And so we will look to, since you mentioned that, next Friday, probably do 9 to 11, a 2-hour block. Make sure you come on time because it really wouldn't be to 11 because I have a class at 11, so I have to leave it. So if you're coming to take a test, then make sure you come no later than like 9:15ish because you want to have, full time to take your test. Because like I said, I do have to leave and go to another class at 11. So, we're not going all the way to 11, but that time would be enough. 9 to like 9:40, 9:45 would still be enough for you guys to knock it out and take advantage of your time that's set aside for you. So next Friday, I most definitely can set aside that time for you to do that. So if you don't want to wait for Mr. Davis, feel free to wait till then. But also, if you know you want to take a test or you know you're behind on your test taking, you need to make sure you're ready for Friday. All right. Anything else? Anybody else? Okay. So you guys have a good one. Be safe. Next class, I'll open up the floor for questions again first. See if you have them. See if any questions were generated over the weekend. And then we'll go from there. All right. You guys have a good one.
You have a good one. Thank you.
Thanks.
Have a great weekend.
Take care.